We now transition from the finite dimensional geometry of bundles to the infinite dimensional algebra of fields. The architecture of the observers provides this stage. We now define the actors. The central entity is a single algebraically decomposable unified field, denoted omega. It is not a collection of disparate fields, but a unified object with bosonic and fermionic subsectors, beta and chi, respectively. This field is native to the 14-dimensional space Y and is a section of the adjoint bundle of the principal bundle P sub H. Its structure is the source code from which the dynamics of reality will be compiled. A critical distinction must be maintained. On the four-dimensional manifold X, there are only topological fields. The metric denoted here by the letter Gimel and its induced Levi-Civita connection, Aleph. These are not dynamical entities in the conventional sense. They are instruments of observation. The dynamical content resides in Y. The unified field omega decomposes into a bosonic sector beta and a fermionic sector chi. These, in turn, are composed of four fundamental components. The bosonic sector consists of epsilon, a nonlinear sigma field, and var pi, an adjoint valued one form. The fermionic sector consists of nu, a spinor, and zeta, a one-form valued spinor. The structure then underpins a core principle of the theory. The arena for affine physics, the physics of translations and linear transformations, is not the approximately flat Minkowski space-time of special relativity. In fact, it is the infinite dimensional affine space of all possible connections on the principal bundle P sub H. This is a strategic relocation of the foundations of field theory from a finite dimensional approximation to an infinite dimensional exact structure. To describe the symmetries of this new arena, the standard gauge group is insufficient. We must construct an apparatus analogous to the Poincare group, which extends the Lorentz group to include space-time translations. We begin with three core definitions. First, script A, the infinite dimensional affine space of all connections. Second, script H, the infinite dimensional group of gauge transformations. And third, script N, the module of an adjoint valued one forms, which serves as the vector space of displacement between any two connections in script A. From these, we construct the inhomogeneous gauge group script G. As the semi-direct product of the gauge group H and the module of translations N. And this multiplication law is then for this new group is explicit here. The product of two elements G1 and G2 involves the standard composition of their gauge components epsilon 1 and epsilon 2. However, the translational component is modified. The translation of the first element var pi 1 is acted upon by the adjoint representation of the inverse of the second element's gauge component epsilon 2 before being added to the second translation var pi 2. This group, script G, acts naturally on the space of connections. The right action of the element G on a connection A is a composition of the standard gauge transformation by epsilon followed by pure translation var pi. This extends the concept of gauge symmetry to include affine displacements in the space of connections. This infinite dimensional apparatus allows for radical recontextualization of supersymmetry. In the standard formulation, supersymmetry generators, the supercharges Q, are posited as algebraic square roots of the space-time momentum operator p mu. Geometric unity proposes a different interpretation of supersymmetry. The fundamental translations are not those in space-time, but in the affine translations within the space of connections, represented by the module script in. The fermionic fields nu and zeta are then interpreted as the potential square roots of these more fundamental translations. The justification, hence, is geometric. The translations in script in are intrinsic to the framework, whereas the space-time translations are an emergent property of a specific solution. This suggests that any superpartners would transform under the inhomogeneous gauge group script G, not the Lorentz group. Their quantum numbers would be then determined by this larger infinite dimensional symmetry. The experimental consequence of this is a null prediction of a specific kind. The superpartners sought in experiments which are based on space-time spin may be a misinstantiation of the idea of supersymmetry. The true partners may already be present in the observed particle spectrum, their nature disguised because they are representations of script G, not the Poincaré group. The action of script G on the unified field omega is what facilitates the mixing of the bosonic and fermionic sectors. The space of physically distinct configurations is the quotient of the space of connection script A by the action of the gauge group script H. This object can be re-expressed using the algebraic structures that we have coined. The choice of a reference connection A0 establishes a canonical origin in the affine space script A, making it isomorphic to the vector space of translation script N. This allows the physical configuration space to be expressed as a double quotient of the inhomogeneous gauge group. The physical interpretation of this final expression is a two-stage reduction of redundancy. The first quotient the first quotient script G divided by script H isolates the space of pure translations in script N. This represents the physically significant gauge invariances between the connections. The second quotient by script H removes the residual gauge symmetry. The full quotient describes the new non-redundant configuration space of the theory. We now synthesize these components into a dynamical framework. The fundamental action principle is an integral of the Lagrangian over the 14-dimensional observerse Y. This Lagrangian is constructed from a kinetic term involving the covariant derivative of the unified field omega and a potential term V. The variational structure dictates the system's dynamics. The action must be stationary under variations of the unified field, and these variations are generated by the full symmetry of the system. Space-time diffeomorphisms parameterized by Z, standard gauge transformations parameterized by epsilon, and new affine transformations parameterized by theta. The resulting field equations take the form of a generalized wave function. The covariant Laplacian acts on the unified field omega here, and is set equal to the variational derivative of the potential. This framework makes a specific prediction about the origin of matter. Spin 1/2 fields are proposed to emerge as elements of the kernel of the covariant derivative operator. Their mass terms are not arbitrary inputs, but are generated from the potential V, which itself is constructed from the translational components of the unified field. Mass is thereby reframed as a measure of the field's interaction with the affine structure of the infinite dimensional space of connections. Thank you for watching.